Hi, Algebra. I'm in our classroom and I thought I would film this way instead so you could see my face and the board as if it was kind of a normal algebra lesson. So I'm going to pretend that this phone is you. So we were doing the combining like terms, and hopefully you feel pretty comfortable with that now. I posted the answers to the homework, but we're doing that so that we can solve equations. So when we were combining like terms, those were not equations. There was no equal sign in them. There was nothing to actually solve. It was all just simplifying, distributing, adding like terms, getting something as simple as we could get it. But today I wanted to start actually solving equations. So an equation is something that has an equal sign in it. So its most simple form would be something like that. So there's an equation that I'm sure that everybody in here knows how to solve at this point. There's no distributing, there's nothing funky. So let's just go through. If I have an equation, see the equal sign, I'm trying to basically strip away everything from x so that I get x by itself. So you've done this before a lot of times. The first thing I'm going to get removed from the x is the subtraction of 5. So I need to do the opposite. So I'm going to add 5 to both sides. I'll be left with 2x. That cancels, equals 16. And then I divide both sides by 2. And what you find in the end is the value for x that works in this equation. Whoops, up here. Okay, so this value of x is the number that works if I were to plug it back in. So we talk about substituting back in and plugging back in a lot. So if I were to take x equals 8 and put it in for x, this equation should work out. That's what an equal sign is there for, to show that the stuff on the left equals the stuff on the right, as long as I find the right x. So when I put x back in here, and I now say, okay, 2 times 8 minus 5, what does that give me? Well, 16 minus 5 gives me 11. Awesome, it checks out. That's what I have on the other side. My equation works. So that's something that you guys have done a lot in 7th and 8th grade. The reason why we've done all of this combining like terms is so that we can get to more complicated equations, not just what we just showed. So let's try another one. Okay, let's get a little more complicated. While you're watching this video, this would be if we were in class and it was a normal year, you would take notes on this. You would write down what I put on the board. As you're at home or listening to this on your own, write down what you need. If this is really easy for you because you've done it before, you don't need to write it down. But at the same time, if this is something that you're like, oh gosh, I really was never very good at solving equations, then write it down. Pause when you need to pause so you have time to write down. That is the good thing about a video. And start it up when you can start it up. So the way I think about an equation is this equal sign really splits my equation into 2 totally distinct parts. And those 2 parts have to be simplified before I start, bringing things over to the other side and stuff like that. So this equal sign, you might think about as a barrier. This equal sign is a barrier, that everything on the left gets simplified and anything on the right gets simplified before I start moving things to other sides. So just go to the left, and I have a 2 that can get distributed. So 2 times 3x is 6x, 2 times minus 2 is a minus 4. And stop and ask yourself, is this as simplified as you can get it? And yes, it is. So now, on the right, I have nothing to simplify. Now I have an equation like I did in the example before. Add 4 to both sides. Divide both sides by 6. I get that value for x. I don't have to go check all the time, but I can if I want to. So I got x equals 2. Let's go check it out. So if I'm going to plug 2 in or substitute 2 in for x, I would have 2 times 3 times 2 minus 2 oops, I won't even write down the equals 8. I just want to see what that ends up being. So order of operations says do parentheses first. Yep, checks out. 8 on both sides. Okay, it gets a little bit harder. So let's make our simplifying a little bit more complicated. Maybe it's not that much more complicated, but again, I've got my equal sign. My equal sign splits the problem into 2 parts. So go to the left and see, is there stuff that I can put together? Are there like terms that I can combine? So yeah, I've got a minus 2x and a plus 3x. I want to put those together. Those are like terms. So remember, this 2x gets the negative. This 3x is positive. Put them together, I get 1x. Do you need the 1 in front of it? You do not. If it makes you more comfortable, great, leave it there. And then I've got my regular numbers without variables, 5, a positive 5, and a minus 4. Becomes positive 1. And now that is reduced as much as I can, and it equals 7. Now I'm ready to go. Subtract 1 from each side. And when I'm here, I am finished. This is what x equals 6. A lot of you in past years will go and divide both sides by 1. You don't have to do that. Once you have 1x, that is what x is. We're figuring out what x equals, what 1x equals. But if you do that, you still will end up with 6. Oh, pardon me. Again, you could go check that. You can put 6 back in to the original equation and have 5 minus 2 times 6 minus 4 plus 3 times 6. Now let's go through. 5 minus 12 is negative 7. Negative 7 minus 4 is negative 11. Negative 11 plus 18 is 7. Checks out. So for today, all of your equations are going to be just like the 3 we just did. You're either going to have to simplify one side by adding like terms, simplify one side by distributing, and maybe adding like terms, or there might not be any simplifying at all. After this, we'll be moving into like fractions and stuff like that. You'll love it. So I've got an assignment up on Classroom. Give that a try, and we'll go from there.